Assalamualaikum students, here we are after a few days. This is my new video, preparation and reactions of the alcohols. So let's start. Preparation of the alcohols. The following are some ways how to prepare alcohol. The first way is the addition of steam into ethanol. The condition needs phosphoric acid. Then we can oxidize ethene into alcohol, ethane 1,2-diol, with the help of an oxidizing agent. Then a neutrophilic substitution reaction in which bromoethane, it means a halogen alkane, react with alkali to make ethanol and sodium bromide. The next one is the conversion of the aldehyde or the ketone into primary and secondary alcohol by a reducing agent. The reducing agent we usually use are either sodium borohydrate or lithium aluminium hydrate. Reaction of the carboxylic acid with sodium borohydrate or lithium aluminium hydrate, or by using hydrogen gas and nickel catalyst. So propanol can be converted into a primary alcohol and propanone converted into a secondary alcohol. Here we have another point that we can hydrolyze a ester by heating it with a dilute acid or alkali. So with the acid it can be converted into carboxylic acid and alcohol, but with alkali convert into carboxylic acid salt and alcohol. Okay, now we are starting with the reactions of alcohols, or we are also called it as the chemical properties of the alcohol. The first one is combustion. Simple. If we ignite the alcohol, it will be converted into carbon dioxide and water. Then substitution to form a halogen alkane, we can add HCl to any ethanol, any alcohol, and convert it into a halogen alkane. Here the HCl can be prepared in situ by the reaction of NaCl and H2SO4. Halogenation of alcohol. For this purpose we are using a reflux operators, and basically alcohol is heated and reflux with the reactants to make halogen alkane. And the nucleophilic substitution by the halide ion takes place after OH group has accepted H plus ions from the acid. This makes CO bond in alcohol, which is easy to break, and water is given off. Next reaction is reaction with SOCl2 and PCl5. In all these reaction, actually we are adding a chlorine atom to the alcohol and convert it into a halogen alkane. You can see in the first one here, the alcohol react with SOCl2 with the formation of halogen alkane and HCl and SO2. This is important what's going to form at the end. Here alcohol react with PCl5, again halogen alkane, HCl and POCl3. In the next one we can heat PCl3 with PCl3 and there is a formation of H3PO3. And if we are using Pi3, then there is again iodoethane with the formation of H3PO3. So actually this is important, that what is formed at the end. In case of SOCl2, SO2 is formed, PCl5, POCl3 formed, PCl3, H3PO3 formed, and Pi3, H3PO3 formed. Then reaction with the sodium metal. When we react the sodium metal with the ethanol, sodium ethoxide along with the hydrogen is formed. If the chain of the hydrocarbon is longer in the alcohol, then it is less vigorous reaction. Otherwise, it is a vigorous reaction. So always there is the formation of hydrogen gas. Okay, esterification. In the esterification, carboxylic acid react with the alcohol like this one. Ethanol plus ethanoic acid, ethyl ethanoate and water is formed. Then we can hydrolyze this esters, refluxing with the acid. And if we hydrolyze the ester, they again convert back into ethanol and ethanoic acid. Then hydrolysis. This is the hydrolysis of ester. At the end you can see there is a formation of a carboxylic acid and alcohol. Or if we react it with NaOH, then there is a formation of sodium salt of carboxylic acid along with the alcohol. Dehydration. If we remove a water molecule from the alcohol, there is a formation of ethene along with the water molecule. The conditions are aluminium oxide as catalyst and heat. You can see the operators which is used for this purpose. Okay, then oxidation. This is very important reaction because with the help of oxidation we can differentiate between different kind of alcohol. Like tertiary alcohol, with the dilute sulfuric acid potassium dichromate, there will be no reaction. So tertiary alcohol cannot be identified with the help of oxidizing agent because oxidizing agent cannot oxidize tertiary alcohol. The secondary alcohol will be oxidized into ketone and the primary alcohol will be oxidized into aldehyde with the help of potassium dichromate. In the meantime, its color will be changed from orange to green. You can see here the primary and secondary alcohol, their color will be changed from orange to green, while tertiary alcohol there will be no change. Okay, here we have a question. This is an important question. When ethanol reacts with sodium metal, ethoxide ions are formed. When water reacts with sodium, OH minus ions are produced. So which statement about these reactions and the ethoxide is correct? The first reaction, obviously sodium ethanol reaction is less vigorous, while they are saying here it is more vigorous. While CH3CHO is a stronger base than OH due to electron donating effect. So this is correct actually. In the C part, charge cannot be delocalized. This is incorrect. And third part, ethanol can donate with more ease than water. Therefore, ethanol is a stronger base. So it is less acidic than water. Now this is an important question. Menthol, which is alcohol, when it is heated with concentrated sulfuric acid, you already know that a water molecule will be released. So which compound, what is the structure of the compound? T. So acid will remove a water molecule from menthol, right? Compound T can be written like this as well. So it means the answer will be D. And here I also put that how the water molecule will be formed. That's it. It's all today for